Well, a lot of people are saying, "Oh, we're going to do all this with AI, all this other, the offensive pen testing stuff like that." If you feed the model every detail of the vulnerability exploit, yes, I've seen it do some amazing things and stuff like that. But I haven't seen it be able to think and all that. I always laugh and tell everybody I was programming AI code in 1987. But when I was doing it in 1987, you had to go check out time in the San Diego supercomputer lab on the Cray system. If you don't know Cray system, do a search on that. And we had to check out that time because nothing else could run the actual algorithms for the actual AI code we were writing in 1987. Today, you have the capability to run that on your phone. So that's the biggest difference. So our biggest challenges now are how much can AI from the hacking side solve the problem of the defenses and penetrate and break through the defenses? And how much from the defensive side is AI going to be able to help us protect our networks? It's a struggle right now. And like I said, I still to this day can't sit down and get it to write me a piece of code that works without me going in and have to test it, debug it, and all that type of stuff. Everybody says, "Oh, go use this product, use that product." I'm like, "Look, I'm just telling you." I ask it a question, and then I'm using it now for some tax stuff, and it's wrong 99% of the time. So we got to find a good tax LLM because right now it's coming up and telling me something and saying, "Oh yeah, you're right, yeah, you're correct," and all that type of stuff. They're polite at least. Yeah, the models are polite. But, yeah. So yeah, that's our challenge now because everybody can program these deep fakes and all that type of stuff. And we go back to that same problem. If a user can circumvent our security, we have risk. And the user being able to click that link circumvents our security. So that's the challenge we have today.
So
That you can buy a product and make yourself secure. Impossible. And the second one would be, oh, I need a third party tool because Windows Defender is not good enough. That's a myth too. Yeah. I teach, as I said, I wrote the CPEN for EC Council Certified Penetration Tester. And you get a Windows 11 with AMSI, AMSI on it, Windows Defender, it's hard to defeat. It's as hard to defeat as all the other stuff out there. But to this day, Windows has a broken kernel because of the way it implemented the Intel architecture. That's a talk for another time. As I tell them, I look my name up live memory, and you'll see me talk about broken kernels for probably 15 years ago, telling everybody why we have all these problems because Windows didn't implement the Intel architecture properly. That's all the trivia question I would like to give everybody. There's two of them. Where did the Windows operating system come from? What OS did they model it off of? Well, that's one of the ones most people don't understand. And the other one is, where did Linux come from? Everybody thinks Unix. No, it wasn't Unix. It was Linux. Andrew Tannenbaum, his operating system book in the back had a CD. Yes, it was that many years ago. And in that CD, he had an operating system called Minix. Mr. Walls took his Minix and customized and derived it to an amazing tool. Don't get me wrong, but all the kernel, everything started out with Tannenbaum. And that's the problem with Windows because they took the digital VAX system. Intel architecture has 4 rings of privilege. Ring 0, kernel level, should be sealed, but it's not. Windows operating systems are ring 0. All your protections are at ring 0. So there's famous rootkits out there. All the attacks, all I got to do is get kernel level. Then I control what every one of your tools see because we're at the same privilege level inside the operating system. After Mark Russinovich of Sysinternals fame joined Windows, they actually blue screened the box. When you try to actually do something outside of user mode and you went to kernel, they were blue screening the box for the longest time. And then they came up with the KPP, the kernel patch protection, and then the hypervisor, where you can lock code into ring 1 and stuff like that. And again, I mean, there's all kinds of paperwork out and show people read about it if they don't know, but just look up some of the challenges. And of course, Jamie Butler and then Greg Hoagland, they kind of wrote a book about subverting the Windows kernel, stuff like that. And it explains all that. So we still have that broken kernel because the kernel is still based on Windows NT. And one of my students, I think it was yesterday, was telling me, why does it say Windows NT? I had to look that one up. I said, because all your kernels are all based off Windows NT. A lot of people look at me when I say Windows NT 4.0, like, what? I'm like, yeah, go look it up. Go look your history lesson up that everything in Windows is based on that NT kernel. A lot of people don't understand that. Yeah.